Good morning. I welcome you all for today's section decade counters. So now we are in course shift registers and counters. So far we have discussed about shift registers, type of shift registers like SISO, SIPO, PASO, PAPO. Then bidirectional shift register, unidirectional shift register, then universal shift registers. So we have discussed all those registers. Also we crossed across counters like ripple counter and what is a counter, types of counters. Now we are going to discuss about decade counter. So decade, from the word decade itself, what do you understand? Decade means it is 10, right? It is a 10. So here this decade counter, that is counts 10 different states and then reset to its initial states. A simple circuit, that is a count, will count that is a states will count from 0 to 9, but we can also make the decade counter which any 10 states between 0 to 15. For example, a 4-bit counter, it has 16 states like 0 to 15, right? So here you can see the truth table from 0 to 10, that is one decade, right? So we know the 8421 code. As per 8421 code, I have framed the truth table like my states are from 0 to 10. Then as per 8421 code, I have given like 0 0 0 1 1 0 1 1, then 0 1 0 1, etc., right? And you can see the circuit diagram here, and this is the circuit diagram which consists of 4 JK flip-flops. This is the circuit diagram which consists of 4 JK flip-flops. So here you have 4 JK flip-flops like flip-flop 1, flip-flop 2, flip-flop 3, flip-flop 4 and one NAND gate. So your input is VCC and I have given a clock pulse here like serial inputs are in serial and outputs are in parallel. So I am giving serial input VCC and a common clock pulse. We are not giving a common clock pulse, we are giving separate clock pulse. See, you can say whether it is a synchronous or asynchronous. Synchronous means we have a common clock pulse. So here we have different clock pulse for each flip-flop, like flip-flop 1, flip-flop 2, flip-flop 3, flip-flop 4. So your outputs may be Q0, Q1, Q2, Q3. Your outputs may be Q0, Q1, Q2, Q3. So these outputs are all given to a common NAND gate. These outputs are given to NAND gates, and this NAND gates output of this NAND gate from Q0, Q1, Q2. So how can we form this NAND gate? See, if my outputs Q0, Q1, Q2 as per our state, I am getting the output. So the decade counters will count any 10 states between 0 to 15. So I need to make all the output as 1. So if my output is not 1, I am giving a NAND gate to get an output as my need like 0 0 0 1 1 0 1 1. So what should I do? From the circuit diagram that we have used NAND gate for Q3 and Q1 and feeding this to clear input line, because binary representation of 10 is 1010, right? And we can see Q3 and Q1 are 1 here. If we give NAND of these two bits, very clear, input these two inputs, the bits to be clear, then the input then counter will be clear at 10 and again start from beginning. Understood? That is, if Q3 and Q1 are 1 and we give NAND of these two bits to clear input, so all the previous inputs will be clear and the counter will be clear at 1 0 and again it will start from the beginning. So the important point here is the number of flip-flops used in counter are always greater than equal to log to n, where n is equal to n number of states here. So n number of states in counter. So this is the operation of decade counters. Okay. Thank you.